Hi, and good day. My name is Jexter Backus, and welcome to TechWiz Club, where tech magic happens. This lesson is a continuation of the previous one. If you have not watched the previous lesson, please watch it first before proceeding to this one. Right now, the fox is able to land on the platform correctly, but there's a small problem: it falls too fast. We will fix this by adjusting the speed and adding an operation to make the movement smoother. Step 1. Understanding the issue. Currently, our fox's movement is being repeated 10 times, making it fall quickly. If we reduce the repeat count to 1, the fox moves more smoothly but feels sluggish after landing. We need a way to keep the movement smooth while avoiding that sluggish effect. Step 2. Keeping the repeat at 10. For now, let's leave the repeat value at 10. This means the movement speed remains fast. But instead of changing the repeat directly, we will adjust how the fox moves inside the loop. Step 3. Adjusting the change in Y movement. 1. Locate the block where the fox's Y position is changing. This is usually done with the change Y by block. 2. Right now, the change Y by block contains speed Y, which controls how fast the fox falls. 3. We will remove speed Y from this block temporarily. 4. Next, go to the operators section and drag the division block onto the workspace. 5. Place this division block inside the change Y by block. 6. Drag speed Y into one side of the division block. 7. Set the other value in the division block to 10. Step 4. What happens now? Since our repeat loop runs 10 times, dividing speed Y by 10 makes the movement more gradual and controlled. This prevents the fox from falling too fast while keeping the movement smooth. Now, when you test the project, you will notice that the fox moves more naturally and lands without a sluggish delay. Great job! Step 5. Refining the collision block. 1. Locate the collision step block. 2. Drag this inside the repeat loop. 3. From there, we can control the value of the collision step. 4. Under the block, when green flag click, find collision block, and set the value to 10. This means the block will now have a value of 10, which will also be applied to our collision detection. This adjustment will make future refinements to collision detection easier. Now that our fox moves and lands smoothly, we are ready to add a jump feature. We will add a jumping ability to our fox and to ensure that our fox can jump properly and only when it is on the ground. Step 1. Create a jump block. 1. Go to the My Blocks category. 2. Click Make a Block and name it Jump, capital J. 3. Uncheck the option Run without screen refresh. 4. Click OK. 5. Move the jump block to a suitable place in your script, preferably after the movement block. Step 2. Detecting key press for jump. 1. Drag the jump block inside the block when green flag clicked, drag it below the movement block. 2. Go to Control and drag a block, if, into the main block, define jump. 3. Go to Sensing and drag the block, key, space, pressed, inside the value of if block. 4. Make sure defined blocks are not overlapping to make the script clearer. Step 4. Adjusting the jump mechanics. 1. Go to Variables. 2. Drag the block, set gravity to value, inside the block, if. 3. Click the drop-down, and change it to speed Y. 4. Set speed Y to 15. 5. Test your project by pressing the green flag and pressing the space key. Hooray! We can now jump and even collide with the platform vertically. Our character can also fall naturally and land perfectly on the floor. However, if you press the space bar rapidly or hold it, our fox starts to fly. To fix this, we need to ensure the fox can only jump when it is on the ground. Step 5. Tracking whether the fox is in the air. 1. Go to Variables and create a new variable called onAir. 2. Always remember that when creating a variable, we start with lowercase letters, and the second word begins with a capital letter, with no spaces. 3. Make sure it is set for this sprite only. 4. Click OK. Step 6. Updating onAir status. We want onAir to increase in value when jumping and reset to 0 when landing. 1. Go to Variables. 2. Drag the block, change drop-down by value, drag it under the block, define collision, place it above the block, repeat. 3. Change the drop-down to onAir and set the value to 1. When we start the game, the onAir variable is always increasing. We will fix this that it will reset back to 0 when landing. Step 7. Reset onAir when landing. Notice how our speed y is 0 when the fox is on the ground. By checking speed y when it reaches 0, we can then set our onAir variable to 0 as well. 1. Go to Control. 2. Drag the block, if. Drag it under the block, define collision. Inside the block, if, touching platform. Above the block, set speed y to 0. 3. Go to Operators. And drag a block, less than. Inside the value of if. 4. Go to Variables. And drag the variable, speed y. Inside the left value of lesser than, and set the right side value to 1. 5. Go to Variables, and drag the block, set drop-down to value. Inside the block, if, speed y lesser than 1. 6. Change the drop-down to, onAir. And set it to, 0. Our onAir value is now set to 0, when landing, and increases when we jump. Step 8. Enforcing jumping rules. Now, let's apply the onAir variable to our jump, allowing our fox to jump only when onAir is less than 3. 1. Focus your screen on the block. Define jump. 2. Go to Controls. 3. Drag a block, if. Under Define jump, and place it inside the block, if key space pressed. 4. Go to Operators. And drag a block, lesser than, and place it inside the value of if. 5. Go to Variable. And drag the variable, onAir, into the left side value of the operator. And set the right side value to 3. 6. Place the block, set speed y to 15, inside this if statement. Test the project to confirm that the fox jumps properly without flying. Great! Our fox can now jump without double jumping or flying by holding the space key. However, when jumping at the edge of a platform, it gets stuck and cannot jump or fall down, although you can still move left or right. This is a bug that we need to fix. We will resolve this by adding X collision detection. However, implementing X collision detection will make things more complex, so we need to improve our code organization. This will make it easier to read and understand how the game runs. To do this, we first need to organize our code. As you can see, our code is already quite complex, especially under the collision section. Jumping, gravity, and movement are relatively easy to understand. But collision detection is more complicated. To make it clearer, we'll restructure our collision block into 3 separate parts. 1. Collision X handles collisions on the X-axis. 2. Collision Y handles collisions on the Y-axis. 3. On ground, checks if the fox is on the ground. Creating the collision X block. 1. Go to My Blocks. 2. Click the button, Make a block. 3. In the block creation window, type collision X, make sure C and X are capitalized. 4. Click the box, add an input. 5. Name the input, steps, all lowercase. 6. Make sure, Run without screen refresh, is not check. 7. Click OK. 8. Arrange and align the block, define collision X, at the right side of the block, define collision. Creating the collision Y block. 1. Click Make a block again. 2. Type collision Y, capital C and Y. 3. Click the Add an Input box. 4. Name the input steps, all lowercase. 5. Make sure, Run without screen refresh, is not check. 6. Click OK. 7. Arrange and align the block, define collision Y, at the right side of the block, define collision X. Creating the on-ground block. 1. Click Make a block one more time. 2. Type on ground, capital O and G. 3. This block does not need an input, so do not check the input box. 4. Make sure, Run without screen refresh, is not check. 5. Click OK. 6. Arrange and align it, at the right side of the block, define collision Y. Now, you have successfully created the collisions, collision E, and on-ground blocks. Try to arrange them properly so they don't overlap each other when we add some code. Implementing the collision blocks. Now, under the block, define collision, let's move everything inside the repeat block. Under, define collision Y. Because all of it belongs there. We also need to move the code intended for on-ground checking. This is an if statement, which is located between set Y to last position and set speed Y to value. Move this code under the block, define on ground. Previously, we stored the Y position in the variable last position. So when our fox collides with the floor, we move it up to the last position before colliding. We can use this last position variable for the X position as well, but that might be a bit confusing. So let's create two separate variables, variable last position X, for the X position, and variable last position Y, for the Y position. Let's add a new variable, last position X, for the X position, and update the variable last position, to last position Y. 1. Go to My Variables. 2. Hover your mouse pointer over the variable, last position. 3. Right-click, and select Rename Variable. 4. Rename the variable to last position Y. 5. Click OK. Adding a new variable, last positions. 1. Go to My Variables. 2. Click Make a Variable. 3. Name the variable, last position X. 4. Select, for this sprite only. 5. Click OK. Creating the collision for X. Now that we have the variable last position X, let's create the collision for X. The layout of collision X will be similar to collision Y, but instead of Y, we will use X. 1. Go to Variables. 2. Drag the block, set, drop down, 2, value, below the block, define collision X. 3. Click the drop down, and choose, last position X. 4. Go to Motion. 5. Drag the block, X position, inside the value of, set last position X. Controlling movement after collision. Now that we are storing the X position, in last position X, when our fox collides with a wall, it will move back to last position X, before the collision happens. Next, let's control our movement. 1. Go to Motion. 2. Drag the block, change X by, value, under define collision X, below the block, set last position X. 3. Just like in collision Y, let's add an operator. 4. Go to Operators. 5. Drag the block, division, inside the value of, change X by. 6. Go to Variables. 7. Drag the block speed X, into the left value of the division. 8. Drag steps, the input of collision X, into the right value of the division. Step 4. Adding an if statement for X collisions. Let's add an if statement to check if we collide with the walls. 1. Go to Controls. 2. Drag the block, if, under define collision X, below the change X by value. 3. Go to Sensing. 4. Drag the block, touching dropdown, under define collision X, inside the value of if statement. 5. Click the dropdown, and select, Platform. We already have an if condition for when we touch the platform. All that's left is to move our fox to the last position after colliding. To do so, 1. Go to Motion. 2. Drag the block, set x2 value, and place it under Define Collisions, inside the block, if. 3. Go to Variables. 4. Drag the variable block, last position x, into the value of, set x. One last thing, we need to make sure that the variable speed x is set to 0, to prevent any further movement that might cause the fox to move inside the wall. To do so, 1. Go to Variables. 2. Drag the block set, drop down, 2, value, under Define Collision x, inside the block, if, below the block, set x to last position x. 3. Click the drop down and select speed x. 4. Set the value to 0. 5. Hover over your scene. Go to Define Movement. And delete the last block, change x by speed x. We need to remove this since it is already handled inside Collision x. 6. To delete, right-click on the block, change x by speed x and choose Delete. Final steps before testing. Before we test this out, we need to do 3 more things. Notice that the repeat block under Define Collision is empty. This means our blocks Define Collision x, Define Collision y, and Define on Ground will not run because they are not connected. To make them run, 1. Go to My Blocks. 2. Drag the block, Collision x, under Define Collision, inside the block, repeat. 3. Beside Collision x, is an input, steps, drag it inside the value of Collision x. 4. Drag the block, Collision y, inside repeat, below Collision x. 5. Beside Collision y, is an input, steps, drag it inside the value of Collision y. 6. Navigate to the block, Define Collision y. 7. Drag the block, on ground, inside the block, if. Between set y to last position y, and set speed y to 0. Let's add a little more platform to better test our collision. We also need to add collision detection under our platform sprite. Now, let's test our fox's movement. Hooray! Our fox can now collide with both the ground and the walls. We have perfected our collision system, as well as the jumping and movement of our character. Let's try adding animation to our fox and see how it goes. Our setup may have some issues when adding animation, but let's test it first and identify any problems. Under our fox sprite, we need to add another when green flag clicked block. This is because our animation uses a wait function, which could cause other functions to pause until the wait is complete. We don't want that to happen. To prevent this, we need to separate our wait functions by adding another when green flag clicked block along with a forever loop. If you haven't added the code yet, add the when green flag clicked block along with the other functions. 1. Go to Events. 2. Drag the block, when green flag clicked, and place it right below our first, when green flag clicked block. 3. Go to Control. 4. Drag a forever loop, and connect it to our second, when green flag clicked block. 5. Drag 2 if statements inside the forever loop. 6. Go to Sensing. 7. Drag a block, key, drop down, pressed, into each if statements condition. 8. Change the first one to A, and the second one to D. We want our character to animate running when we press A or D. 1. Go to Looks. 2. Drag the block next costume into both if statements. 3. To control the speed of the animation, we need to add a wait function. 4. Go to Control. 5. Drag the block, wait, below each next costume block. 6. Change both wait to 0.1 seconds. Try pressing the green flag and moving your character. You may notice that the movement feels laggy, but when you jump, it becomes smooth again. This happens because our run animation changes frames, and some frames collide with the floor, causing the character to stop. To fix this, we need to separate the animation sprite from the main code. Instead of controlling movement directly on the animated fox, we will use a box to handle movement and jumping. Then, we will make the animated fox follow the box's movement. 1. Click your fox sprite. 2. Go to the Costumes tab. 3. Click on the second costume to use it as a reference for our box. 4. Draw a box on top of the sprite. 5. Make sure the box exactly covers the size of the fox. 6. You can switch between outline and fill to adjust the box properly. Also, set the outline thickness to 1 for better accuracy. Seven. Delete the rest of the fox sprite. Now, we have a box the same size as our fox, which we can use to handle collision detection. Next, let's create a new sprite for our animated fox. To upload a new fox sprite, 1. Go to the Sprite panel. 2. Hover your mouse over Choose a Sprite. 3. Click Paint to create a custom sprite. 4. Under the Costumes tab, hover over Choose a Costume, located in the lower left corner of the screen. 5. Click Upload Costume. 6. Locate the fox sprite from the Assets folder. 7. Select the first fox, then hold Shift and click the last fox to select all frames. 8. Click Open to upload them. 9. Don't forget to delete the first empty sprite of the fox. 10. Change the scale of the fox to 200. 11. Rename the sprite to fox_animation. Now, we have our animated fox sprite ready. To make our animation follow the box and animate running, 1. Go to the box sprite. 2. Drag the entire code under the second, when green flag clicked, to the fox_animation sprite. 3. Right-click and delete the code under the box sprite. 4. Let's create 2 more variables under the box sprite. 5. Go to Variables. 6. Click Make a Variable. 7. Name it Position X. 8. Make sure to select for all sprites. This is very important for our fox animation to follow. 9. Click OK. 10. Repeat the process to create another variable named Position Y. Now that we have these variables, let's update them based on our box's position. 1. Go to Variables. 2. Drag the block, Set, drop down, 2, Value, and place it under Define Movement, right below Set Speed X. 3. Click the drop-down, and select Position X. 4. Go to Motion. 5. Drag the block, X position, into the value of, Set Position X. 6. Repeat the same steps for position Y. Now that we have set up the position X and position Y variables, let's update our Fox underscore animation so it follows these values. 1. Click on the Fox underscore animation sprite. 2. Go to Motion. 3. Drag the block go to X, value, Y, value, into the script. 4. Go to Variables. 5. Drag the variable position X into the X value of the go to X, Y, block. 6. Drag the variable position Y into the Y value of the same block. When playing the game, you might notice that our Fox underscore animation feels sluggish. This is because of the wait function inside our forever loop. To fix this: 1. Make sure you are in the Fox underscore animation sprite. 2. Create another block, when green flag clicked. 3.
Drag a forever loop and transfer the go to X, position X, Y, position Y, inside it.
4. Play the game again. Hooray! Our Fox now animates and follows the box smoothly. Hiding the box now, let's hide the box sprite so only the Fox underscore animation is visible. 1. Make sure you are in the box sprite. 2. Go to Looks. 3. Drag the block, Change, Effect, By, Value, under the Define Initials block. 4. Click the drop-down and select Ghost. 5. Set the value to 100. Great! Now our Fox is now able to move, jump, collide and animate perfectly. Can you make the Fox face left and right? Based on our previous discussion, try making the Fox flip left and right depending on the direction it's moving. Give it a try. Next lesson, expanding our game. In the next lesson, we'll add gems for the player to collect, obstacles to make the game more challenging, a stage to bring our game to life. Keep up the great work. Thank you for listening, TechWiz Club. This is your guide, Jexter Backus.